Hello guys and welcome to another video. Today we are talking about enums, which is short for enumerations. This is a feature in Rust which allows you to define a type by enumerating all its possible variants. So let's dive straight into it. Let's say for example we are coding a game in which a player can choose between two different moves, a left move and a right move. We can represent it with an enum just like that. So we're gonna write enum and then the name of the enum, which will be move, and then inside the curly brackets we are gonna display all the possibilities, which in this case are just left and right. Okay, that's cool. You've written your first enum. How can we use it? For example, we can instantiate a variable which will be a left move. So let left equals to move, then double colons, and then left. So this tells us that the left variable is a left type of the move enum. We can do the same thing with the right move. Okay, that's great. So if you want to display one of them to the standard output, we can do something like this. Player move, and then we are gonna debug it. So we're gonna tell our compiler that enum derives the debug trait. Okay, so we're ready. We can compile it. So cargo run, and then execute it. Okay, of course we are not using the right variable right now, but the console prints this message, which is pretty cool. Okay, let's say that now we want our player to move in one direction but by a certain length. So we're gonna need also an integer representing how many steps in certain direction the player is taking. So we can retain this move enum and then extend it with a struct. So we're gonna define a move struct that will have a direction field, which will be a move enum, and then a length, which will be just an integer. And we're gonna derive the debug trait also on this. So instead of doing this, we can just instantiate a move struct. And let's say that the player is moving left by a step long 3. Okay. So we can print it. Again in debug mode. Let's see what the script is gonna say. So let's compile it and run. Okay, we are going. Of course, here I have to tell that left is a kind of move. Now it should be okay. Okay. So as you can see here, player move, and then we have the display of the move struct. Okay, this is pretty neat, but if you think about it, we are just using a structure just to store a direction and then an integer. Maybe we can do it all in one shot. Actually, an enum can store multiple values in their variants. So for example, we can get rid of the structure and of all the code inside. And we can declare that we want the variants of the move enum to store an integer inside of them. Just like that. So in this case, we are going to have that our move will be move type left, and then inside parentheses we are going to store the length, which will be 5. So again, we can print it out. And as you can see here, the result is pretty much the same. Okay guys? And now I'm gonna introduce you to another pattern, which is the match pattern. This is a nice feature which is pretty unique in Rust because it makes it easy to run different code for different values of an enum, which is actually what we're looking for. So for example, let's say that we want to do different things for different moves. So we're gonna do something if the player moves left and something if the player moves right. And this is how we can build a match. So the match pattern will be match, and then the variable that we're gonna test against. And then we have the so-called match arms, which are all the possibilities or all the branches of the code. So if we have a move left, then what we're gonna do, player moves left, and then since left accepts an integer, we can do like this, player moves left by L. Okay, then we separate the arm with a comma, and then we can proceed on to the next arm, which in this case will be pretty much the same, but we are gonna test against the right move. So player moves right. Okay, in this case the workflow is pretty much the same, but you could define different behaviors for the two different cases. So just out of curiosity, let's change this to right. So as you can see here, is keeping the first arm, the first branch, and moving just to the second one, which in this case is just a println invocation. Another cool feature in Rust is the option type. So let's say, for example, we do not want our player to move left or right at every turn. Maybe he can rest, restores his health, or perform some other kind of action. So sometimes we are not going to assign a move value to our variable. And we can enforce it by using the option type. So we can define an enum option, which will be of type move. And this will have two values, sum, move, and this tells us that option will contain a value. Otherwise, it will be none, and this tells the compiler that inside the enum there's no value. So we can instantiate it like this. So let's say, for example, we do not want to assign a move to the player. So this will be an option of type move, which will be none. Or we can just say none. I think actually this is the right thing to do. So here we have two branches, we can add another one. So if we have none, we can print to the standard output player is inactive, or maybe player is deciding for other actions. So let's just clear the output. Okay, here we have, that's right. Okay, because in this case we are treating them just like an option, so we have to test if there's a value inside of it. Okay, now it should be okay. Sorry again. Okay, so player here is inactive. So guys, this is pretty much all that concerns the enumerations. We've seen how we can encapsulate it into an option if we are not sure if we're going to assign a value to this enum. So thank you guys for watching, and on to the next video.